Hello, Sprang Gang, and welcome to your first video notes. Today we're going to be talking about arc lengths and areas of sectors. So, first thing we need to talk about with every geometry lesson, we need to talk about the vocab. So today I'm going to be using these two terms, arc length and sectors, a lot today. So, when we're working with a circle, the sector of a circle is literally just this like pie slice that we want out of a circle. So it would be all of this would be the sector of a circle. Okay. So the way I kind of define it, it's not like not really a textbook definition here, but it's a pie slice of a circle. Okay. And it's basically, I guess the textbook definition would be the area between two radii. So we have a radius here, we have a radius here. The sector is just the area between those two radius. Sectors could also be very large. So in this case, we're thinking of it like as this pie slice, but also a sector area could be everything else. This all could be here, could be considered a sector as well, because it's an area between two radii. So that's what an area of a sector is. All right, cool. So that's the first thing, sector. Now the next part, the next vocab word we need to talk about is the arc length. So an arc. So an arc is kind of like the circumference, but it's only part of it. So it is the distance around the circle from one radius to another. So that's what an arc is. And today we're going to be looking in depth at how to find the area of a sector and how to find the length of an arc here. Okay, so we're going to be, the formulas, or actually you guys already know a lot of it, but we're going to put it to the test. All right, so first one we're going to talk about is the sector, I guess. So the formula for a sector is going to look very familiar to you guys because you guys have already talked about the area of a circle. So now the area of a sector is just part of the area of a circle. So the formula is going to be very similar to what you've seen before. So the area of a sector is just equal to, well, it's going to be like pi r squared. So r being your radii, but it's only going to be a portion of the circle. It's not going to be the entire circle because that's not what a sector is. A sector is just, this little bit right here, or this little bit right here. So instead, we need to incorporate how many degrees this sector takes up. Okay, and that angle is just the angle between your two radii. And since we know how many degrees are in an entire circle, like if I were to go from here to here, that would be 360 degrees, right? So if I only wanted part of that, I would just take, theta's worth, I guess, this unknown amount's worth of degrees of the circle. So for the area of a sector, all it is just that many degree measures divided by 360 pi r squared. That's it. So it's literally the area of a circle times, how many degree measures divided by 160. That's it. All right. Now I bet you guys could even come up with the arc length on your own if you wanted to. I think you guys would know that pretty easily based off of, area of a sector. So arc length corresponds to the circumference of a circle, right? So the arc length is just a portion of that whole circumference. What portion is it? Well, it's this angle measure over 360 of it. So, okay, getting back to that. So arc length is just a portion of the circumference. So we're gonna start off by just writing out this formula for the circumference, which is 2 pi r, right? And just like before, we're only gonna take a portion of it. So we're gonna take theta's worth of the whole circle. So theta over 360, 2 pi r. But this looks a little kind of janky, so we're going to simplify it a little bit. If I multiplied theta by 2, I'd have 2 theta over 360, which we can simplify to 180. So it's just theta over 180 pi r. That's it, pi r. And that is your formula for the arc length. And up here is your formula for the area of a sector. So these two formulas are what we're going to be using a lot today, as well as other for area formulas as well. Great. So moving on. So today we're going to have a big idea that we're going to talk about is how to find the area of, let's say this shaded area. Now this is called a segment technically, but I like to call it like the sliver. It's just like a little sliver of the circle. So in order to find this little sliver, that's cut off by like a triangle inside the circle, to find that sliver, what we have to do is we have to find the area of the whole segment here. So all of this area, we have to find all that area. Then we have to subtract out. Oh, so this is the area of the segment, or sorry, not segment. The area of the sector. Thanks. I lost my words there for a second. So we have to find the area of the sector, and then we have to subtract out this little triangle thing. So we take the area of the sector, we subtract out the area of the triangle, and that's going to get us this little sliver area here. Okay. So that's going to come up today in, our problems and stuff like that, and on your homework for that matter. So kind of get used to that idea. Here's another example of trying to find the area of the shaded area. So here I have a circle, right? Here I have a circle and there's a triangle inside. How would you guys find the area of just these little like slivers here? Well, one way you could do it is find the area of the circle. Oh dear. The area of the circle, and you could subtract out the area of the triangle, and that would get you the shaded area, right? Now let's say this is an equilateral triangle just for fun. What if I wanted you to find, let's say I wanted you to find just these two areas. What could you do to alter this to figure out just these two shaded areas? Take a second, answer it on your own. We're going to Dora Explorer this for a second. You're right. Yeah, nice job. Yeah, so you would take this whole thing here and you would multiply it by a fraction. So instead of wanting all these shaded areas, you want 2 out of the 3 of them, right? And that would get you these 2 shaded areas here. So that's just some like kind of examples of some higher level stuff that you guys are going to be expected to do. Okay, you're going to be expected to find like these little areas here. You're going to be expected to find weird, like subtract out weird shapes and stuff like that in order to find certain areas. Okay, so this whole like subtraction idea and addition idea with areas is going to come up a lot in this lesson. Okay, so let's give it a shot. All right. So these 2 problems are really wordy. I'm just going to check. Okay, cool. These 2 problems are really wordy here. All right. So number 20 and number 24, you got to really read them, draw a picture, make sure you know what's going on. So from point P, PA and PB are drawn tangent to circle O at points A and B. So we haven't gone over circles yet, but tangent means that if I have a circle, the line that's tangent to it is only going to touch the circle at one point. That's what tangent means, okay? So just keep that in mind. The circle O at points A and B. If the radius of the circle is 6 and angle APB is 60, find the area of the region outside the circle but inside the quadrilateral AOBP. Whoa, okay. So let's draw a couple of things here. So we have a circle. Boom. Okay, this is circle O. And we have tangents, PA and PB are drawn to O at points A and B. So we're going to draw A down here and B up here. And we have point P somewhere out here. Boop. Boop. Okay. If the radius of the circle is 6 and angle APB is 60, so this is 60 here, find the area of the region outside the circle but inside the quadrilateral. This is point O. A, O, B, P. Okay, so they want you guys to find this area right here. All right. So another thing, the reason I do circles unit before this unit is because there's a couple of things that you guys need to know with circles to like do some of these problems. So my bad on that. But B and A here, a property of something being tangent is that the radius is going to be perpendicular to the line of tangency. So these angles here are actually 90 degrees. So we're going to draw in there 90 degrees there. Which means that this angle measure here, if this is a quadrilateral, this angle measure here has got to be, well, 360 minus 180 is going to be 180 minus 60 is going to be 120. So this angle here is going to be 120. All right. Now, in order to find, now thinking of it more generally, the area of the shaded region. So the area of the shaded region, how are we going to get that? Well, the shaded region is the area outside the circle, but it's inside the quadrilateral. So I think in order to find that, we need to find the area of this quadrilateral. And then we need to subtract out the area of the sector. So we're going to find the area of this whole big thing, and we're going to subtract out this sector. And that should get us this purple shaded area. All right. So let's tackle the area of the quadrilateral first, since I think it's going to be a little bit more difficult to find the area of the quadrilateral. So here, I'm seeing some interesting angle measures. So I got 90, which is great. And then I have 60 and 120. I think I could construct a line to make this problem a lot easier. Do you guys see it? So we could construct a line that goes, let me erase this real quick. So this angle was 120. I could draw a line that goes from the radius here over to point P. And what type of triangles are these going to be now? Yeah, they're going to be 30, 60, 90 triangles, right? So this angle here is 30, this angle is 90, this angle is 60. Luckily, we are given the radius of the circle here is 6. So we know that here and here, these have a length of 6. Yes, this radius of the circle is 6. So these have a length of 6. So by that, we know that we have, if this is a 30, 60, 90 triangle and my small side is 6, that means my medium side here is going to be 6 root 3. So now in order to find the area of the quadrilateral, it's just, since we have two triangles, it's 2 times 1/2, so that cancels out, base times height. So it's going to be 6 times 6 root 3. So that's the area of the quadrilateral. Now we need to find the area of the sector. So the area of the sector is just going to be, well, we got to go back up and look at our formula. Our formula here for the area of the sector is theta over 360 pi r squared, where theta is the angle measure, r is the length of the radius. In our problem, we know this angle measures 120, and this r is 6. So this angle, so this is also 60. So this whole angle measure here, the angle of the sector is 120. So we're going to have 120 over 360 times pi r, which is 6 squared. So that means the area of the shaded region is 36 root 3 minus, I'm going to have to bust out my calculator here. 120 divided by 360 is the third, I believe. Yes, it is. Times 36 is going to be equal to 12, so 12 pi. And that is as far as we can simplify it. We're leaving it in simplest radical form and in terms of pi. So there you go. The pink area is equal to 36 root 3 minus 12 pi. Okay. So that's 20. Now 24. So this is an example of using the subtraction of areas to figure out the shaded areas. You're going to have to do that a lot in you guys' homework. All right, so moving on. ABCD is a square with sides 8 centimeters long. 2 circles with radius 8 centimeters are drawn. One with center A and the other with center C. Find the area of the region inside both circles. Okay, so let's draw a picture. So we're going to draw a square ABCD. That's close enough. Okay, so A, B, C, D. All right, square with sides 8 centimeters long. 2 circles with radius 8 centimeters are drawn. One with center at A. So we're going to draw a circle here. So it's going to go like this. Oof. So the circles have a radius of 8, which means that if my center of the circle is here at A and my radius is 8, it's going to go through points B and D. So it's going to look something like this. and big circle. All right, cool. And the other was center of C. So we have a center of C here. We have radius 8 and 8. So I'll draw a circle looking like this. Cool. Find the area of the region inside both circles. So the area that they want us to find here is this area. All right. So in order to do that, there's a couple ways we can do it. So, 1 second. All right, so what do you notice about both of these circles, I guess? Well, they have the same radius, which is great. And they both go through points B and D. So in order to find this like section, there's actually a couple ways you can do it. But the way that I'm going to do it is I'm going to find this sliver here. I'm going to find this sliver here, which is the sliver for circle C. And then I'm going to do the same thing on the other side. I'm going to find this sliver here for circle A. So I'm going to do it like this. So A sliver, that's the sliver for A. And I'm going to do C sliver over here. Okay, honestly though, I'm actually going to move it. Honestly though, since these have the same radius, these things are going to be this equal to each other. So A sliver is going to be equal to C sliver. The reason being is they have the same radius and the same angle measure here. So we just need to find one of these slivers, multiply by 2, and we're good to go. So I'm actually going to redraw this so that it's easier to see so we can find the area of that sliver. I need a different color. I'll do this. Okay, so I'm going to redraw it down here. Boom, boom, boom. I got my square. And here's my circle. We're going to do it for circle C. And then I'm going to draw. Oh, gosh, that's so bad. Let me redraw that. Center here at C. It's going to go something like that. And I'm going to draw this right here. Boom. Okay. So this has 8 and 8. It's a square, so we know that this is 90 degrees. So let's start off by, if we look back up here, to find the sliver, we have to find the area of the sector, then the area of the triangle, and then that will give us the area of the sliver. So we're looking for this sliver right here. So first thing we need to do is find the area of the sector. So the area of the sector is just equal to 90 over 360 pi r, which is 8 squared. So that will give me, so this is 1/4. 8 squared is 64. So 64 times a fourth is 16. So this is going to be 16 pi. All right. So that's the area of the sector. Now, so that's the area of the whole sector. Now we're going to find the area of the triangle. So the area of the triangle is not hard to find here. It's just 1/2 base times height, which it's 8 and 8. So it's just 1/2 8 squared. So that is 64 divided by 2 is 32. So then that means my area of my sliver is just going to be the area of the sector, which is 16 pi, minus the area of the triangle, which is 32, and that is the area of the sliver. So what we just found with this example is we found the area of this sliver right here. Now, since circle A has the same radius and angle measure as C, then we know that these two slivers are going to be the same. So to find the area of the shaded region, so to find this whole area of the shaded region, I'll do it in a different color. Oh, you know what? I should actually write right here. We found the area of a sliver. The area of a sliver is 16 pi minus 32. All right, so anyways, to find the area of the whole shaded region, all we have to do is take this and multiply it by 2. Two times 16 pi minus 32. Which is going to be equal to 32 pi minus 64. And that's the answer. That's the area, that whole shaded area region. There is another way to do it. And if you guys find out the other way to do this problem, then let me know in the comments below. All right. Okay, lastly, we got this problem. This is one of the more challenging problems that you guys are going to run into for this problem, or for this unit. So here we have circles X and Y with radius 6 and 2. They're tangent to each other. So tangent to each other means they only touch at one point, which is right here. AB is a common external tangent, so that means that this line here is tangent to both of these guys, which means it only touches them once and it makes 90-degree angles with the radius. Find the area of the shaded region. Oh, there's no shaded region. The shaded region area should be this area. They want you to find this area. All right. So it asks, hey, what kind of figure is AXYB? What is the measure of AXY? All right. So let's start filling some stuff in. So circles X and Y with radius of 6 and 2. So X has a radius of 6, which means that XA is 6, and this distance here is 6 as well. And this one has a radius of 2. So that's 2, and that's 2 right there. All right, so we are going to have to construct a line here. So the line that I think that would be useful for us to construct is this line right here. So I'm going to construct this line that's going to be perpendicular to both these radii. Now that's the hardest part of this problem, is actually figuring out what to do with your construction. So I constructed this line that's perpendicular to both sides here, which means that this shape is a rectangle, right? So that's cool. So that's a rectangle. And this shape here is a right triangle, which is also cool. So we know that since this side is 6 here, we know that this distance right here has got to be 4. Okay, because if this whole side's 6 and this side's 2, then 6 minus 2 is going to give me 4. And now we can actually find the length of this. Since this is a right triangle, we can use the Pythagorean Theorem. 8 squared, which is the hypotenuse, is equal to 4 squared, one of my sides, plus this last side, x squared. So solve this. So we have 64 is equal to 16 plus x squared. Subtract 16 from both sides. So 64 minus 16 is 48. So I get 48 is equal to x squared. So square root both sides. X is equal to square root of 48. Nice. I believe that can be simplified. 48 divided by 4. Ooh. 48 divided by 16. Oh, okay. So this is going to be equal to 4 root 3 is this side. So now let's think about how am I going to find the area of this shaded region? Well, we're going to have to do some subtraction. So the area of the shaded region is going to be equal to this big figure. So the area of the quadrilateral, so quadrilateral, minus, so it's this big figure, right? If we find this whole area, it's minus what? What do I need to take away in order to just be left with this segment or this portion here? Well, you need to take away these two angle measures. Yeah. So we need to subtract out, or sorry, we need to take away these two sectors. So minus area of both sectors. Okay. So let's break this down. There, the quadrilateral, we're going to break that down first. So it's going to be the area of the square or the rectangle plus the area of the triangle. Okay. Minus my two sectors. So area of both sectors. I'm just going to write that. Okay. So the area of the rectangle is just going to be length times width. So 2 times 4 root 3. So that's the area of the rectangle, and then the area of the triangle is 1/2 my base, which is, it could be either of these. We'll say it's 4 root 3 times my height, which is 4. Minus, now we're going to do the area of both sectors. Okay, so we'll start with the big sector. So this is the second tricky part of this question. So this triangle here has sides 4, 4 root 3, and this side here is 8. Do we know of any triangles, any special triangles that follow the pattern something, something root 3, and then two times that small side, something? We do. We actually know that this pattern here follows that a 30, 60, 90 triangle. So this angle here is going to be 60. This angle here is going to be 30. And that helps us out tremendously because it gives us the angle measure of this sector here and this sector here for that matter. So the angle of the big sector is going to be 60 degrees. So the area of the big sector is 60 over 360 pi r in this case is 6 squared. So that's my big sector. Now let's do my small sector. What's the angle measure of my small sector here? Well, we have this 90-degree angle, and this angle here is 30 because it's part of the 30, 60, 90 triangle. So that angle measure in total is 120. So we're going to have 120 over 360 pi, and then r is 2 for this case, so 2 squared. Now it's just a bunch of number crunching at this point. We got it conceptually down. We just got a number crunch. So this is going to be 8 root 3 This is going to be 8 root 3 as well. So 4 times 4 is 16. 16 divided by 2 is 8. And then we have this root 3, so 8 root 3 as well. Minus, okay, this is going to be a little bit more work. 360 divided by 6 is 60 divided by 360 is 1/6 times pi, and then 6 squared is 36. So 36 divided by 6 is 6. So this is going to be 6 pi minus 120 divided by 360 is a third. So a third times 2 pi. So that's going to be 4. So this is going to be 4/3. And then simplifying it in the end, here this is going to be what? 16 root 3s. And then I'm going to change this. So this is going to be 18 over 3 pi. So 4 minus that, that'll make it 14. So minus 14 over 3 pi. All right, so we did it. So this is going to be probably the most involved type of problem you guys are going to do. Just to recap this problem, what we did is, in order to find the area of the shaded region, we constructed a line that made this into a rectangle and this into a triangle. We subtracted the side here to get this 6 minus 2 to get me this little bit 4. We used Pythagorean Theorem to find that third side, 4 root 3. And then we said, okay, we got our shapes down. Now, in order to find the area of the shaded region, we need to take this big shape and we need to subtract away from it these two sectors. So this sector and the sector. We subtract those out. So we did that. There, the rectangle is pretty easy, length times width. There, the triangle, pretty easy, just 1/2 length times, or base times height. And then here we knew that this triangle followed the pattern of a 30, 60, 90 triangle. So we were able to find that this angle here is 60, this angle here is 30. So we used these angle measures in our area of sector formula. And we ended up with the area of the shaded region here. So this stuff, the big takeaway I want you guys to get away from this is the idea of finding different areas based on, subtracting a bigger area, taking a big area and subtracting out a smaller area in order to get, the leftover area, which is what we have here and what we did in all these problems, okay? So those are going to be the hardest type of problems you guys are going to have to do. Anyways, so thank you guys all for listening. Good luck with your notes. If you have any questions, ask me during class or leave them in the comments below. Thank you all for your time and have a great day.